Hello and welcome to this new video about algorithmics. Today's algorithm is called minimum number of moves to seat everyone. So the problem describes that we have students and seats. We're going to have the same number of students and the same number of seats. So the amount of seats is the same as the amount of students. And the goal is to move the students to to be seated with the minimum cost. So for example, let's take some examples. So we're gonna have, for example, 3 seats and 3 students. The seat number 1 is at the position 3. Seat number 2 is at position 1. Seat number 3 at the position 5. And the 3 students, the student number 1 at position 2, student number 2 at position 7, and student number 3 at position 4. And the goal is to seat every student. So for example, the first students at position 2, in order to be seated at this position 3, we can move it by 1 position. So the cost is going to be 1 to move it here. This student at position 7, in order to move to position 1, we need to move it by 6 positions. So the cost is 6. So far, 1 plus 6. And the cost of moving this last student at position 4 to 5 is 1. So the total moves that we did is 7, I believe is 7 positions. But the problem can be solved better. Like the goal is to find the best solution, the minimum cost to move all students to the positions. In this example, they say the best solution is a 4, and they give an explanation. By the way, if you like to access this descriptions of problems and also the solutions, I will put in the description my website where I put all the courses that I have. You can choose by your level. For example, if you are a medium level, you can find all the courses that I did and the videos. And if you click on any, you can find the assignment and the solution, and also the explanation, which is the video that I'm making right now. So please just visit the website and you can play with it. Yes, so let's understand a little bit the problem. So we have, as we said, 3 seats and 3 students. The goal is to move all the students to the seats here. And so for example, this student on position 2, in order to move to position 3, the amount of moves is what? Is a 1. This one, the amount of position that's from 7 to 1 is a 6. And the last one, from 5 to 5 is a 0. This is an example. Let's take another combination. So we can take another color so it's clearer. So in order, for example, to move 3 to math 7. So what's going to be the cost from 3 to 7 is the difference, which is 4. So from 1 to 2 is a 1, and from 5 to 5 is a 0. So as you can see, the problem becomes like a matching. It's like how many combinations can we make, and what's the sum of the difference between the combinations. This seems like a C. In math, we call it like how many combinations in 2 of n, I guess, here, or n, which is, if you compute it, is an n factorial times 2 factorial divided, no, it's not a 2 factorial, sorry. It's an n minus 2 factorial divided by 2 factorial. This is like quite expensive, and we basically then, once we find all the combinations, every combination we have to sum all the costs. This is quite expensive. Can we do better? That's the question. Can we do it in a smart way? And yes, of course, we can do it in a better and more performance way. And I'm going to describe to you this solution. So let's draw again another example. So we said, let's just say, for example, we have 3 seeded, 3, 1, and 5. So I'm gonna draw them here. So we have the seed number 1 is at position 3. The seed number 2 is at position 1, and seed number 3 is at position 5. And then now let's take students. So we have 3 students, the same length, which is, let's just say, student number 1, student number at position 6, and at position 7. So all we do is let's put them in their position. So this one is here at position 2. This one is here at position 6. And the last one is here at position 7. So as you can see, if this was a real scenario, what's going to happen? So this guy has 2 options. Has to go here or to go here. And this guy has to go here or here. And this guy, the best is to go here, right? 7, if it goes more, it's just going to be more expensive for 7. So if 7 goes to 5, naturally 6 has to go to 3. And if 3 is taken, 2 has to go to 1. And this is the best solution, right? Let's take another example. Let's take, for example, minus at position -3. I think we should just work with positive numbers. So let's just say 2, 1, and the 6. So first one is going to be here at number 2. The other one is going to be here at position 1. And the last one is going to be here at position 6, right? So as you can see, this one is already seeded, right? So it's good, but also can go to this one. Number 2 can go to this one or this one. But 6 can only go to this one, right? So clearly we can see that 6 has to go to 5, which is the closest. 2 has to go to 3, and 1 has to go to 1. So as a conclusion, if the list is ordered, the moment they get ordered, because here, as you can see, they are ordered like 1 to 6 and 1 to 3, 5. If we achieve an ordered state of the seats and the students, the problem becomes very simple. Basically, every combination at the same, so the first student in the first position is first seat, they should be combined, and the second student in the second seat should be also combined, and that's it. But what's the cost of sorting the students and the seats? It's an n log of n, which is way better than what we saw as, which is S2n times n, I guess. This is the complexity that we saw before. So all we need to do is just sort the arrays, and basically we have solved the problem. So let's do it. So I'm going to start by sorting the seats. A, B, A minus B. So depending on the language that you are using, you're going to use different ways of sorting, but it doesn't matter. All we need to do is just sort the array. You can look it up in your language that you are using. And we're going to also sort it. A minus B. And so this is what I said. This is an n log of n complexity, and this is an n also log of n. So 2 times n log of n, and we always neglect the constants. So 2 is going to just go away, and we keep the complexity, which is n log of n. And then now the seats and the students are sorted. We're going to create a variable called results that we're going to initiate by 0, and then we're going to return results at the end. And then all I need to do is loop in over through the seats and students. So I'm going to like let I equal to 0, I smaller than seats dot plus plus, because the length of seats and students is the same, so I'm just going to take the length of any, and every time I need to add to result the difference between position of the seats and the students, which is the absolute value of the difference. So seats of I minus students at the position I. There you go. Let's see if the test passed. So all the tests they passed here. Let's submit the problem. And there you go. It's very performance. It's good enough. And yeah, so yeah, I hope it's clear enough to understand for you guys. And if you have questions, please put them in the comments and I will do my best to answer. And if you like the explanation, please give a thumbs up to the video and consider subscribing for more videos. And if you like to play on your own time, please visit my website and you can find all the classes. I put more classes frequently. So basically on a daily basis, I put more classes. So you can keep being updated. Yeah, so I'll see you in the next one.